Write this down right here. Properties of inverses. I have, well, a few things to show you here. Properties of inverses. Now, watch what I'm going to do here. This is really easy, but I don't want you to work the problem out completely when you don't have to. Just write down what I just put there. And then right underneath that, write down this. There. Properties of inverses. These would be like the easiest problems you would see on a test for inverses. After today, everything's done. Tomorrow's going to be my normal day before test type of thing. I'll go through everything and tell you how it's going to be set up. Right now, this test is scheduled for Monday. All right, look at this. If you have the inverse sine of x, and you're going to take the sine of the inverse sine, what do you think the answer would be every single time, no matter what? When you take the inverse of something, aren't you doing like the opposite of it? So if I had the sine of the inverse sine of x, what do you think that would equal every single time? There'd be no work to show you guys. It'd be like the easiest problem I could ever put on a test. Think. Jimmy. No. It's in the problem. It would be that simple. There would be absolutely nothing to do. The sine of the inverse sine of anything. I don't care what x is what I'm trying to say. What do you think the answer would be every single time? Howard?
Sine of x
No, you're giving me too much.
would just be x.
So listen to what I'm going to say here, and I'm going to make it ugly on purpose. If I said to you, what's the sine of the arc sine of 371 over 91? The answer is 371 over 91. I mean, think about it. You got an inverse sine, and you're going to take the sine of that. Well, one's undoing the other, so you're going to be right back where you started. Now, I'm not going to write them all out. If I had cosine of arc cosine, tan of arc tan, you hear what I'm saying? Secant of arc secant. No matter what I have, if these are the same, the answer is just whatever x is. All right, so that's pretty simple. Look at the second thing I wrote down. Cosine of the arc secant of x. Now, come on, be smart. You know this. What do you think that would equal? Look at those two things right there. What are they? You've known it for the longest time in here. If you take the cosine of the inverse secant of anything, what do you think the answer would be every single time? That's right. Now, I'm not going to write them all down, but just listen to what I'm saying. If I had sine of arc cosecant, if I had tan of arc cotan, you see what I'm doing? If I had cotan of arc tan, the ones that are reciprocals, the answer would just be 1 over x. So if I had, what's the cosine of the arc secant of 2 radical 3 over 5, if you had that on a test, tell me all you would have to do. And it's a pretty simple problem, but tell me what you would do if that was on the test. Because you know what you don't want to do? This would be a big mistake on your part. You don't want to start doing like I showed you yesterday and get the x's, y's, and r's. You're wasting your time. So whenever you have a trig function of an inverse and it's a reciprocal, you would simply do what here? Rob?
Flip it and then
5 over 2 radical 3. And then you would just go to your answer, right? Okay, so that's done. That was pretty simple. All right, now here's the big thing I want to do today. Let's start with problem A right here. Write this one down, problem A. I got just 2 things to show you here today. First, And you will have one on the test very similar to this. Write this one down. Get rid of this. Now, I've been pretty consistent with this for the last few days. What do you think you're going to do to start the problem? I want you to keep using what I've been giving you the last 2 days, because you're not going to get this answer all in one step. How have we been starting these problems for the last 2 days? We've been starting them the same way every time. Max?
Would it be let y?
Yeah, let y equal that, right? So go ahead and write that down. Let y equal arc sine of radical 2 over 2. Now, I've been doing this, today's Thursday, ever since Monday. What does that mean? You always got to write down what it means. What's that mean? Howard?
Sine of y equals radical 2 over 2.
Quadrant? First, right? Whenever it's positive, it's always the first, right? Now, listen to this. Do I have to get x, y's, and r's in this problem like I was doing yesterday? The answer is no. I would like one of you to tell me why. The answer is no. This isn't a problem where you got to do x's, y's, and r's like I was doing yesterday. Now, you must have understood that pretty good, because practically all of you had that turned in yesterday by the end of the period. I'll give you those back tomorrow. Why aren't you going to do x's, y's, and r's? John? That's a special angle value. What's the angle? Now, I'm just going to give you a fair warning on this. This is just to keep in mind. When you take this test Monday, if you don't know your special angle formulas, you realize you will not get a good grade on this test. Got to know your special angle formulas. What's the angle there, Ethan? 45. Okay, now he said 45. Now listen to what I'm going to say. You need to give it to me in radians in this problem. Now, would one of you like to tell me why? Look at the problem. You need to give me this angle in radians. See, this is where you got to use common sense. Jack. Because see what I have there? That's radians. So what's 45 degrees in radians? Got to know your special angles. David. Okay, now take a look here. This problem's almost done. Let's go back to the original problem. Cosine. Now, what does that parenthesis equal? We just did it. What does that parenthesis equal? We just did it. Rob. Was that, right? Watch this. Cosine of pi over 4 plus pi. Somebody talk to me. What do you think you're going to have to do there? Just basic arithmetic, actually. What do you think you're going to have to do with what you see in the brackets? Andrew?
Get a common denominator.
Adam, get a common denominator. That's over 1. What's it going to be? What's it going to be? Rob?
2 pi over 4. Or pi over 2.
Well, wait a minute. Isn't this 4 pi over 4? When you get a common denominator?
4 pi over 5 pi over 4.
Do you all see that would be 5 pi over 4? Remember, so many pi over 4? That's 45-degree increments, right? Who can tell me what quadrant 5 pi over 4 is in? Now, guys, in your mind, you got your x and y axis. This is all special angle stuff. In what quadrant is 5 pi over 4? Joe?
3.
Do you understand that, everybody? Look, 45-degree increments. 45, 45, 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4 is right there. So will the answer to this be positive or negative? Have to be negative, right? Because cosine is negative. What's the reference angle? right there. Come on. This is all stuff you already know. What's that little reference angle there? Then you're gonna give me the answer. Rob?
225.
No. What's the reference angle?
45.
What's cosine 45? The answer. What's a cosine of 45? Ethan. So because it's in the third, it's negative radical 2 over 2. One of the problems on the test Monday will be very similar to this. In fact, one of your homework problems will be like this. Everybody good? One more thing to show you. Okay, put problem B, put B and C next to each other in your notebook. Now watch this. Put B and C next to each other in your notebook. Put B and C next to each other in your notebook.
Which B?
Oh, I'm sorry, right here. What? Right here. B, C. Boys, let me just say this first. See how I wrote this here? You know, the -1? You all realize that means the same as arc sine of 1/4, right? Remember, there were two different ways to write that. Okay, how are you gonna start both of these? Come on, start in the same way. But watch what's gonna happen at the end of the problem. How are you gonna start both of them? Come on, you already know, I've been doing it the last 2 days. Andrew?
Y equals
No, not completely. Now, come on, this is where you gotta be heads up here. Not completely right. Not completely right. He said let y equal what's like in that bracket. No, not completely. What do we always let the y equal? See what I'm getting at here? Jack,
arctan.
just the arc part, not the 2. Watch this. Look. So now write in your notebook. You'll see y here in a minute. Let y equal arctan of negative 8/15. And then over here, let y equal inverse sine of 1/4. You're not doing anything with the 2 yet. You're going to see shortly here where the 2 is going to come into play. Okay, now go ahead and write down what each of them mean, just like you've been doing. So here, tan of y equals negative 8/15. Over here, sine of y equals 1/4. Now that's the same as I was doing yesterday. Okay, now, this is obviously quadrant 1 because it's positive. Now, be careful here. What quadrant is this one? This is inverse tan. You know how they're either 1 or 4 or 1 or 2? Don't screw that up. This is inverse tan. What quadrant does this one have to be in? Max?
4.
4. Now, you seem like you all did real good with this yesterday. You understand in these 2 problems, I got to get the x, y's, and r's again. It's not a special angle value. You all clear on that? Okay, so what's the trig definition for tan? So far, this is the same as yesterday. John?
X over R.
No,
Oh,
that's not right. Y over x. And what's the trig definition for sine? Howard?
Y over R.
Now remember, r is always positive. So this is y over x. Now remember, you're in quadrant 4 here. Down here. Give me the values. The minus sign is for the 8 or the 15. It's not for both of them. You're in the 4th quadrant. Which one's going to be the negative one? Ethan?
Y.
So y is equal to what?
Negative 8.
Negative 8. And x equals 15. Okay, go ahead and get your r. R squared equals x squared, which would be 225, plus y squared would be 64, right? So 225 and 64 is 289. Now this one's coming out nice, isn't it? Why am I saying that? Or don't you recognize it? Yeah, a lot of you aren't seeing it. What's the square root of 289? It's perfect. That's why I'm saying that. Rob? 17 times 17 is 289. So this is 17. All right, let me come over here. Give me the values here. Give me the y and the r here. What is it? Ethan.
Y equals 1, R equals 4.
Okay, so r squared would be 16 equals x squared plus y squared is 1. So it looks like x squared is, put the 1 over here, 15. So what's x? Noah? Okay, now watch this. Watch this. Go back to the original problem. Sine, bring it over. Now, remember what you let y equal. You only let y equal what I underlined. So what's in the bracket now? Sine of what? Watch this. I know hopefully you'll remember this as soon as you see it. We just said let y equal this, right? So if I put y in for that, all of this is just what? Because you got the 2 in front. Dave?
It would be 2 and -8.
No. We started the problem by saying let y equal that inverse tan.
So it's 2 times whatever y is.
It's 2y. Look. Do you see what I'm doing here? Didn't we say let y equal this? So when I come back to the original problem, I got the sine of 2y. Do you see that? Over here. This will be the cosine of, same deal, 2y. Now, come on. We just took a test not too long ago on this stuff. What are those? We just took the test on it, what, last week? Oh, you just forget so fast. What are, look at how they both turned out. They're both, this is disappointing. Jimmy, double angles. Now, if you need formulas on the next test, I will still give them to you, just like I did before, just to refresh your memory. What was the formula for the sine of a double angle? It was this. Now, make sure you're writing this down. That was the formula for the sine of a double angle. And for the cosine of a double angle, I think the one we used most of the time was that. Whoops, of y. So what does it look like you have to know? And then you're just going to plug them in and get the answer. Boys, you know all the x, y's, and r's here, don't you? So isn't it going to be pretty easy to determine what sine of y and cosine of y are? Here, let me erase this. Sine of y, cosine of y. What's the sine of y equal in problem B? Look, this is all you need, everybody. Remember, if you know the x, y's, and the r's, you can find anything for trig. What's the sine of y equal in that problem? Let's use your definition. Howard?
15 over 17 for sine.
Well, it's y over r for sine.
Oh,
So negative 8/17. Who has a question? What's the cosine of y? Just plug in your definition. Ethan.
15 over 17.
You see all you got to do to get the answer now, don't you? Go over there. Put them in. 2 times sine of y is negative 8/17 times cosine of y is 15/17. Don't worry what the number looks like. Here's where a lot of you guys, where you're going to get an answer, go, well, that can't be right. Like there's a rule, number can't be big. Well, the denominator's gotta be what? 17 times 17, we know from before, it's 289, right? Okay, somebody wanna figure out what that top's gonna be? 2 times -8 is -16. Somebody, figure out, what's -16 times 15? That's what's going up there. Noah?
240.
240? And I know some of you are sitting there going, what the heck kind of an answer that is that? Look,
Negative, oh, wait, negative 40.
it is what it is. Don't worry about what the number is. And then over here, all you need is cosine of y. Well, what's the cosine of y? Look, once you know this stuff, you know everything you need. What's cosine of y? What's the definition? X over r, right? What's x over r gonna be there? Look, what's x over r gonna be there? Mike?
Radical 15 over 4.
Radical 15 over 4. Okay, here we go. Put it in. Cosine squared. Square that. You're just putting it into the double angle formula. Ethan,
15, 16.
minus 1. Common denominator. Quinn,
-1 over 16.
you're gonna have 5 problems here. Now, I wanna take your iPads out. I'm gonna start one of these. 6 problems, excuse me. Go to page 248 in your book.